Hey guys, in this video, we're going to be talking about lesson 4 of module 12, which continues our discussion about organizing and analyzing data. Now, the very first page of this set of notes is all informational. So there's vocabulary to look over, a lot of information on correlation coefficient and those types of things. Now, before you panic because of all the words here, I want you to understand that you need to know what a correlation coefficient is, but we are not going to calculate any of this by hand. There's a wonderful tool called Desmos, which I know you've all heard of before, that we are going to use in order to calculate the correlation coefficient. So I'm going to move ahead right to example 2 and show you kind of how that's going to look. The first thing that I want you to know, actually, if you look at the very end of the notes, you should see directions on how to use the Desmos graphing calculator in order to do the things that I'm about to talk about here in the graph. So I'm going to show you the most basic parts. I want you to fiddle around with Desmos. I'm fairly confident that you guys will know how to do this, and you will use these directions to find the information that I will give you in the answers for each example. Okay, so for example number 2, it says use the bivariate data. So bi meaning 2, so 2 variables, that's guessed and cost. So bivariate data below to draw a scatter plot. Draw a line of best fit and write an equation of the line, and then estimate the correlation coefficient. Now, the nice thing for you guys is instead of making you do most of this by hand, after you graph the scatter plot, you're going to go straight into Desmos and you are going to put the table in using this information down at the bottom, and it will populate all the rest of the answers that you need for this. So you just need to understand how to use Desmos. So if you're going through this and you're trying it on your own and it doesn't quite make sense, I need you to come in and see me so we can talk about it, or find a friend and have them help you through it. Okay? All right, so it says Ashley had guests for dinner at her house 8 times and has recorded the number of guests and the total cost for each meal in the table. So here's the table here. We know that the number of guests is our independent variable, or our x, and the cost is y. Our dependent variable is y. And that's, you can see that in the table here, right? So we have guests down here on the x-axis, costs down here on the y. So the first thing we need to do is graph a scatter plot. All right, now a lot of these you might have to estimate, and that's okay. It doesn't have to be perfect, but we are going to sketch that here. So for 2 guests, the cost was $25, which is somewhere around here. 3 guests was $30, which is slightly higher. 4 guests was $65, which is somewhere up here. Oh, another time they had 4 guests, it was $88, so they must have had something a little more expensive that day. 6 guests was $90, which is just under 100 here. Another time it was $115, so somewhere in the middle. 7 guests was $160, which is way up here. 8 guests was $150, which is just below $160. And then 8 guests was $162, so just above here. Okay, so there's our scatter plot. Now what I need to do is calculate the correlation and describe the connection. So here is where you would go ahead and use Desmos. So use, my pen doesn't want to work. Use Desmos to calculate the correlation coefficient. So again, the directions are down here at the bottom of the next page. Once you do that, if you did it properly, you should get R is 0.957. That's the R that you get, which is a very strong positive correlation. And the way that I can tell that it's very strong and positive is just by looking at the number. First of all, the number is positive, so that's why I chose a positive correlation. And secondly, the closer you get to 1 for your R value, the stronger your correlation is. So if you look at the dots too, they are fairly close together, so that makes it strong, and the R supports that as well, okay? So now what I want you to do is I want you to calculate the line of best fit. So what that means is it is a line that represents the data, not perfectly because it's the dots are not in a straight line, but it is a line that can represent the data and give you an estimate of the cost based on the number of guests that you have for dinner. Again, you're going to use Desmos for this. It can do it for you. Just follow the directions, and if you do it correctly, you should get y equals 23.1x minus 24.9. That is the equation that you could get. And then what I'm going to do is take this equation and calculate the cost of dinner for 15 people. Now remember, our x value here is the number of guests, and the y is the cost. So I'm going to take this 15 and I'm going to plug it in for x because that is my number of guests. So I have y equals 23.1 times 15 minus 24.9. And when you calculate that out, you get y is, and that's dollars, so $298.75. So again, I have 15 people. I'm going to estimate how much those 15 people are going to cost me for my dinner party by taking the 15 and plugging it in for x. Again, this is a minus, not a plus there. Okay? All right, let's try another example. Again, you're going to focus on using Desmos for these. So I'm going to show you the scatter plot, and then I'm going to give you the answers for the line of best fit and what the correlation coefficient is. Your job is to try it out using Desmos on your own using these instructions. Okay? All right, so this one's talking about animals. It says the data show the amount of milk that a baby goat needs by its weight. So once again, weight, the top is our independent variable, our x, and the y is going to be the amount of milk that the goat needs based on their weight. So what we need to do first here is label our graph. So I'm going to go ahead and do, I don't know, every other line will be 5. So this here is 5, 10, etc. Okay, so that's the weight of the goat. So I'll put weight down here. And this is milk in ounces. Let's see, we need to get all the way up to 80 for this one. So we'll count by 5s, but not skip lines this time. So this will be 10. Okay, and now what I'm going to do is I am going to plot each of those points. So 5 pounds, I think it is pounds. So 5 pounds needs about 12 ounces. So this is 10 and that's 15, so somewhere in the middle. 7 pounds, which let's see, that's about here-ish, needs 16 ounces. So that's somewhere about there. 10 pounds needs 20 ounces. 15 pounds needs 28 ounces, which is getting closer to 30. 20 pounds needs 32. 25 pounds needs 40. 30 pounds needs 48, which is just under 50. 40 pounds needs 64. So somewhere about there. And 50 pounds needs 80 ounces. So if I'm looking at my graph here, that is a very, very straight line. So when I get my correlation coefficient, first of all, it's positive. So I should assume that my R value is positive. And I should get a number very, very close to 1 because that line is almost perfectly straight. So my R should not be 1, but it should be close to it. So if you follow the directions at the bottom of the page here to do the Desmos, it should help you find the information that we need here. So once you do that, you should get an R value of, pen is acting up again, 0.9984. So once again, that is very strong. So strong, positive correlation. Almost causation, but not quite. And if you go to find the line of best fit using Desmos, you should get y equals 1.48x plus 4.52, which could be used to approximate the amount of milk in ounces that a goat would need based on its weight, which is x. All right, let's try one more. The data shows the U.S. desktop online sales on Cyber Monday since 2009, okay? So once again, we need to start with the scatter plot, and then we will let Desmos do the rest of the work, okay? Now, to make it simple down here at the bottom, instead of writing in 2009, 2010, 11, 12, etc., I'm going to say years after 2009. So that means the year 2009 is year 0, 10 is 1, 11 is 2, etc. Okay, and then I'm going to do the sales, and it says it's in millions. Okay. All right, let's go ahead and skip lines here. So 1, 2, 3, okay, and then I need to get up to 2,671. So let's just do 300 for every other one. And then we're going to plot all those points. All right, so it's 0, 887, just somewhere around here. 1, 10, 28, so 1,028. Somewhere about there. Okay, 2 is 1251. 3 is 1465. 4 is 1735. 5 is 2038. 6 is 2280. And 7 is 2671. Somehow I think this data may be a little off. I don't know where it came from, but I feel like the number of desktop computers sales is not increasing. It's more laptops, but what do I know? Anyways, so we're going to use Desmos once again to find the information that it asks for here. Again, this line is increasing, so it should be a positive correlation, and they are very close together, so it should also be very close to 1. And when you go in and you do this, you should get R equals 0.9935, which is what I expected. It is a strong positive correlation. Again, not causation, because the R value is not 1, so you can't say causation. And then the line of best fit you get should be Y equals 254.5x plus 778.6. And that's it. That's how you use data to, or that's how you analyze and organize data using a scatter plot.